Good afternoon, YouTubers. Today we're going to be studying the chart through an orifice meter, something like this, as shown on this picture. And basically, what we're going to do is to set up in Solidworks, in flow simulation, to see how close we get to this design here. Like for example, flow go in this direction. There's a contraction here, what we call a small orifice, and there's a pressure drop, a lot of vortex here, and that create a differential pressure. And so the main point of our design is to take a look to that, like what's happening on this area after the orifice, in front of it and after it. So we're going to design something like this in SolidWorks, and we'll see. We will calculate then, or SolidWorks will calculate the flow based on the pressure here and the pressure here. For example, if this is discharging to atmospheric pressure here and you have a pump pushing water at a certain pressure here, so you just set the pressure here and the pressure here and let SolidWorks to work its magic on the simulation to calculate the flow rate. So that's what we're going to do. And obviously the pressure drop as well here. All right, so let's go to SolidWorks. All right, so this is basically what we're going to be constructing, this kind of a flow through an orifice. You can see the orifice back there, and if I do a cut on the pipe, let's see how that looks like. You see how the taps are located. This is the pressure tap number 1, and this is the pressure tap number 2. This is basically about 2 diameter distant from the center orifice here, shown here, and this is the one that is about a half of diameter location for measuring the pressure drop as the flow goes through the pipe. So let's say that's what we're gonna design. Very simple. So let's start with saying new here, and so let's do a new part here. And basically what we're gonna do, let's change this a little bit. Let me change that to white millimeters, and that will be good enough. So let's start by front plane, and on the front plane let's build quickly 2 circles here. 1, 2, oops, let's put another one. That's good enough. Let's do the dimension on this circle. Let's say that the internal diameter, let's start by the outside diameter, that's 30.4, and the internal one will be about that's the one for the internal diameter, 25.4, just to make an inch. And now let's do the extrusion on this one. So what we're gonna do is features, extrude. Now the extrusion here will be mid plane, and it's gonna be about 12 inches, but we are working on millimeters. That's 25.4, and here you have it, and that's the pipe. So I can select the contour, but pretty much know that I'm gonna be doing a pipe here, with hollow here. So we're gonna accept that, and we're done. Now the idea to do this mid plane is because we're gonna do now back again front plane. We're gonna do a sketch there, and that sketch, what we're gonna do on that sketch is basically, let's convert this entity. So you can select it, convert entity, and now let's do a circle again for the orifice, and let's pick on that orifice. If I remember that right, it was about half of the pipe diameter, so it's about 12. You can put the 25.4 divided by 2, and you get the diameter, right? So now we go features, and now in feature we're going to extrude, and this is what we're going to do. We're going to extrude mid plane again, but obviously It's not that. It's gonna be like a washer. Let's say 5 millimeters. And let's take a look. That looks good. And leave it as merged, so it's only one piece, one body there. So we accept that, and that looks good. That's right where it should be. See? Now we want to take a look to what's going on here. Let's change the reference to I can use that one. That one's better. See how that looks like? I can pull this out, and you can see the internal part of our construction. So we accept it and we get out of here, and basically what we need to do just to create the tabs, and we're done. So let's create the tab. To create the tab, we need to create a new plane, and that's gonna be from what plane? You know that we're gonna create a tab here somewhere. So we're gonna do that from the top plane, and we're gonna create a reference plane, and that reference plane we're gonna set it like 20 millimeters more. I remember last time I did something like this. 20 millimeters is good enough, and it's going the right direction. So like for example, you need to flip it, then you have to flip upside, but the way it is right now is perfect. So take this out, and that's where I want it. So we accept that there, and that's the plane. Within that plane, we're gonna create now a sketch. So we're gonna create sketch, and on that sketch we're gonna take let's put that in front of us so we know what we're doing. And here's the story. We want to create a center line to align our tabs the way we want them. So from there to here, that's our center line. Escape from here, and now we want to create two circles at a certain distance. Let's create two circles here. One circle, I can put the circle anywhere, and let's get that circle. It's about should be that should be about 12.7, and what we're gonna do, we're gonna move that guy somewhere within this guy, and so now let's see, and let's see if I can relocate it. That's the one that is, this is the idea. The idea is the flow will go through this pipe like this, so this need to be located about a certain distance. This circle need to be about half of the diameter. So let's get this back the way I want it, and let's see. So I want the distance of that guy versus this center. That distance should be about half of the diameter. So that means 25.4 divided by 2, and that's perfect. That's where I want it. Now I want another of that guy, an identical circle of that. Again, just right anywhere, and then do the same size, which is about 12.7 again. And let's locate that guy. That guy need to be, that center need to be located. Hit Control as you press the other line, and then, oops, sorry, I still have the escape. Now that guy, hit Control the line. Now pick coincident, and now pick for the distance. So go back to Smart Dimension and pick from here to here, and that distance is the one that you want to be like 2 diameter. So it's going to be 2 times 25.4, and that's perfect from the center. So actually should be the distance, I think. Let's see. No, I'm thinking here the diameter actually here should be 10. Sorry for this. The diameter is 10, smaller, and this is also smaller. Obviously, it's 10 as well. Here we go. Fix that. That's so there. The distance is right. The center, the distance from here to here, from the center top, is half of the diameter of the pipe, and this is 2 times the diameter. The location of this top is 2 diameter from the center. And remember, this is the center where the we have the orifice right there, and this obviously come from here, which from the center to these 2 diameter and versus half of the diameter here, where you are right on the vena contracta, right here. So going back to SolidWorks, so that's where we are now. I think that we got that straight, and now basically we're going to extrude, and this is what we're going to do. Put it this way because it's going to extrude to touching the pipe here. So we're going to go features, extrude, and it's right there. It's showing you what's the direction, but here instead of mid plane, it's going to be up to surface. What the surface is this guy, and you can see how nice they looks like. And I don't think that we have to do anything else here. It's still merged because it's just one pipe, one body. So it looks like we are in good shape here. So let's say okay, and that looks super. Let's get the plane out, hide that plane so it doesn't bother, and that start to look a lot like what it's supposed to be. So you got that located right here, that top, and the center right there, and the other top right here. But this top need to be opened. So basically what we're gonna do now is on this surface, let's create another sketch, and let's get that straight, and let's get this big, and let's create the hole for the pressure. Now you don't see the center. This is sometimes bothers me a little bit, but just mess around until you see it, and when you see it, then do the circle where you want it. And that circle is about we're gonna do a cut there, so that's gonna be about 6 millimeter. Let's put it here somewhere so I can see it. 6, and we're gonna do the same on this one. So let's pick the circle again, and this should be at the same plane. So sometimes it's kind of weird, but they are at the same plane, so I can do the circle as well here. And we're gonna set 6. We're gonna accept that, and now we are ready to do the cut. And this is gonna look very good. Features, extrude cut, and now we're going down. How much down? We want to pass through, so you can drop this until you see it coming down, and that's perfect. So we accept that, and that look good. So we are pretty much done there, and we have the tops done. Now you want to take a look to how this start to looks like. You can start to move this around. Let's see. You see? There we go. You see the tops right there. Now, the top are to locate kind of pressure sensor in essence, but we're gonna do flow simulation. So basically, we're gonna put a seal. We're gonna seal these guys so there's no flow out or anything. And so for that, we're gonna put those seals. Let's get this out the way, and we're gonna seal these guys. So what we basically what we're gonna do is create a solid here on that surface. So create that. Now we got a sketch there, put that in front of you, and from there you can take a circle and make that circle big enough there. And we're gonna do the same with this guy until we locate that center. Bingo. And now we got that sketch, and the only thing that we need to do is to extrude. Now for the extrusion, they don't need to be that big, so we're gonna do like a 5 millimeters. Let's see how that looks like. That's perfect, you see. And I think we got that straight, we got that done. It is sealed, and we accept that. And here is your let's take a look here. What's that? This looks like it. I think that I merged them. I shouldn't merge them. Let's go back here for 1 second. I don't want to merge them. And this is a story. This is interesting. If you merge them, then, like for example, it's one body. If I hide the body, and let's say you hide it, you hide everything, and that's not good because I want to see those seals at one point in time. So this is going back here again. Let's show the whole thing, but let's go back here and go back here to edit that. And instead of having that merge, we want them like another entity, like another body, and we're gonna accept that. So we got two bodies there. We're gonna accept them, and now all of a sudden we have three bodies, which is the pipe and the two seals, and that's kind of nice. Now it's perfect. And let's take a look how this start to looks like. And you can see that the flow, there's a seal right there, and the idea is to locate in flow simulation a pressure. You're gonna install there something to measure the pressure in that point and the pressure here, so you can get a nice delta P for your flow simulation. And as per you are designing an Orifice kind of a flow measurement device. So let's say that we accept this and we add her here. And the next thing is, let's put here right names, like for example, let's see, let's rename that one as Orifice. Let's see, let's put everything cap Orifice pipe. And then let's call this one, that's the first one, we're gonna call that one pressure tap 1, pressure tap 1, and we're gonna call that one, this one here, we're gonna rename that guy as pressure tap 2, and we're done. So anything else here? Nope, we are done. That's basically it. The nice thing is that right now you can hide this one away, but then you can look into these faces. These faces are important, like that face or this face, for locating where you want to measure the pressure on your flow simulation system. So let's put this back, and we are done, ready to do flow simulation. See you on the next one. All right, let's go to Wizard. And let's go to this project here. It's gonna be Orifice pipe flow sim. And next pressure is gonna be pound inch square, pound inch square, psi. It's gonna be this guy. Now flow is gonna be here. Load and motion, mass flow rate, that's okay. Volume flow rate, this guy, let's change it to gallons per minute. Gallon per minute. I wish I can open this a little bit more so I can see what I'm doing. It doesn't show what is the volume flow rate. Is gallon, US gallon per minute, but that will do. All right, so next it's gonna be obviously fluid flow internal, and we're gonna exclude cavity without flow condition. Excellent. So anything else here? How about gravity? It's gonna be on the Y, so that's gonna be negative 9.81. and we get this one out of the way. A 0. How about the dependency? Well, the dependency of this guy is on Z. You know, I've been told, but it's not active, so I don't care. Rotation, nothing resurface, nope. Next, liquid, it's gonna be water. Double click, nothing. Laminar and turbulent, that's okay. Next, roughness is smooth. Next, no, I mean default wall, adiabatic wall, not a chain of heat or anything. Next, pressure, turbulence. I'm gonna stick with this system, and that's intensity and length, so it's gonna stay the way it is. Coordinate system. I don't have anything here to change, unless the reference really want to put the reference to be the Z. If anything, let's go to C here, accept, okay, and we finish. And here's the computational. It's gonna say that there's an error because I need to do the watertight concept here. Let's say yes. So we're gonna set this guy, and we're gonna set this guy as well. There we go. And this is pretty much the length. If you want to increase a little bit more or less, but that sounds great to me. Leave it the way it is. Okay. So yes. This one were sealed by me, so you don't. They don't need. You don't need to do anything on them. Boundary condition. Insert boundary condition. Inlet velocity, pressure, static pressure. 30 psi. Goals. Volume flow rate. All right. And then and X pressure, static pressure. Goals, volume flow rate, accept. Let's see, check geometry again. There we go. Now they realized what was the issue. You had to set the boundary and then check geometry. Now it knows that there's a flow there. Good. Alright, so good. We are good. We are going to clear now. So we are out of here. And now let's get the pressure here and here. So let's set another goal, surface goal here. Surface, insert surface goal. What surface? This is the nice thing about this, that surface. On that face, I want the static pressure. The average will be more than enough. and the static pressure on that face. Then tap uno, tap one. I'm gonna add another goal. Insert surface goal. That's gonna be this guy. Static pressure, average. We're gonna accept that. And that's gonna be tap, tap two. We got tap one, tap two. We're gonna accept that. Now, what about the mesh? The mesh, let's see. Let's go to file and let's apply the mesh. Let's say okay. Let's see how that will work out. About 29,000. All right. Insert boundary condition, and let's get this on. But this guy, the lead one, let's hide that body so I can see the inside. Now, delete this guy, and now pick the inside. Okay. Now, let's get the other out. Delete two as well. Hide. So let's see. All that is wall, it's not moving. I want to see what's the effect it has on everything. There we go. I think I got all the faces. All the faces, and those are here. Real wall. No speed. There we go. So we're gonna accept that. All right. So let's do a run. Actually, let's check on the global mesh again. Create mesh just in case with those changes. Let's see if I got anything new here. Increase it to 33,000. May increase a little bit more. So let's run Solidworks. I should make this wall as well. I missed it from the analysis, but let's see. Let's do a run. Run. Solve new calculation. All right. Put all of them. least I see the pressure that makes sense. 25.6 versus 20. And dropping. And the flow. These numbers should be obviously identical, one coming in, one coming out. That makes sense. Well, on the top, the pressure drop is about 10 pounds. The top one is getting close to the inlet pressure, which is about 30 psi. And the top number 2, 9.81, 9.76, for a total flow of 24 or so. Pressure pretty much, the flow rate pretty much right on the spot, 24 gallons per minute. That's a lot of flow. That's why the pressure drop is about 10 pounds pressure drop here. About 24 gallons per minute in a 1-inch pipe. Pretty much converging. Pretty much done. Yep. That's it. Now let's take a look to see how this looks like now. Start with flow trajectory, insert. What we're gonna do, we're gonna insert, let's get the pipe orifice out, high. Let's bring this guy on, and this one as well. And this is what we're gonna do. We're gonna use, for this, we're gonna use that face, and that face as well. And that looks pretty much the way it should be. I'm talking about pressure here. That looks like textbooks. What we got here? I got pressure. Let's change this to velocity. And let's accept that. Let's see. There's a red. There's a high velocity right at the orifice. Whoa, 17 meters per second. That's a lot, right there. And then drop to blue. Blue, very low pressure. Very low velocity right here at the end. And actually, the velocity is pretty much close to. Much different between here and here. It's on the contraction that really kick in. Alright, a little bit of animation. Let's see. Animation, flow trajectory, play. Okay, flow trajectory. Stop that. And let me put the pipe. Let me put this one. That should be Uh, that will do. Mhm. There we go. Even better. Leave it right there. That's what's happening. Now we can go back here to flow and check on this one. Animation, edit definition. I use how many? 20, about 100, just to see it better. Oops. 100 lines, accept that. I would like to see what's going on here. It seems like a waste of volume. I don't know. Let's see. Flow trajectories. Play. Let's check on the contour. Stop. High. There we go. Wow, the amount of noise as the flow goes through that orifice is huge. Must be very noisy. This is basically it. Nothing more to it. Have a great day. Bye.